Hello and welcome to the next important lecture in the module Stats the way to do it. So today's lecture will be on simple linear regression, which is also called as SLR. So regression is all about understanding the relationships in the data. Let us proceed to the agenda of the lecture. So what is the meaning of relationship in data? How the relationship can be measured, so measure of relationship, then straight line fitting. Then we are here with one beautiful example of performance of swimmer. So the entire lecture will be in context of swimmer performance, how it is measured, what are the relationships, and then in the concluding part, you will see the steps to develop the SLR model for measuring the swimmer performance. And finally, in this lecture, we will develop SLR model in context of performance of swimmer. And the data is also real, so you will enjoy the lecture very well. So what is the meaning of relationship in the data? So it is a logical connection between two or more factors. So when we talk about relationship, we always have some factors out of which some factors are dependent and some are independent. So relationships are based on interaction of these factors, how these factors interact. So if I give you the example of purchasing power and income, so I can say that purchasing power depends on the income, but income does not depend on the purchasing power. So likewise, there are many factors and there are different types of relationship between them. Now let's come to the context of a swimmer. So if we want to analyze the performance of swimmer, first we have to decide the measure of betterness. That how will you evaluate that a swimmer is a good swimmer or a bad swimmer? So here the measure of betterness is selected as swim lap time. So whatever the time a swimmer consumes for completing the lap, that time we will measure as a measure of betterness. So we can say a good swimmer will take lesser time to complete the lap. So the target is to minimize the swim lap time. Now, what is this lap time? It is a measure of betterness. So it is impacted by many factors such as age of the swimmer, weight of the swimmer, height of the swimmer, sex of the swimmer, and then there will be more factors which we will eventually see in the coming slide. But we want to understand the relationship between these factors with our measure of betterness, that is lap time. So what is the relationship of age with lap time? What is the relationship of weight with lap time? What is the relationship of height with lap time? And this relationship, if we are able to understand, then we can make the decisions accordingly for optimizing the lap time. That is, in this case, we want to minimize the lap time. So this is the crux of how the relationship between the data is important. Now we will proceed to next slide. Now if there is a relationship, we want to measure it. So the graphs in front of you are showing no relationship. Why no relationship? The line, the black line you can see is entirely horizontal. So I am talking about the left graph, which means that the value of y is constant when the value of x is changing. So if I take x as age of a swimmer and y as lap time, so this graph is showing that if the age of swimmer is increasing, there is no change in lap time. Let's say this second graph is for weight of the swimmer versus lap time. So if the weight of the swimmer will increase, there is no change in lap time. But in real life, it is not so. You also know that swimming is a kind of floating activity. So if weight of the swimmer will increase, it will definitely have some impact in the lap time. So linear relationship. So this was the graph for no relationship. Then we are seeing linear relationship. Here we can say that if x is increasing, my y is also increasing. And in the second graph, if my x is increasing, the y is decreasing. So this is called as linear relationship. There are many other kind of relationship, one of which is curvilinear. So it is not represented by a straight line but a curve. Then let us talk about the quantum of relationship. What is the density of the relationship? So you can see the black line is a straight line in which we are trying to fit the data. So more the points which are nearer to the black line, it will indicate the strength of the relationship. So you can see here in both the graphs, all the violet points are near to the black line, while in the right side graph, the points are scattered away from the black line. So it is the indication of weak relationship. Now coming to straight line fitting. Now why we are using the straight line? Because straight line is something which gives us the relationship in the form of straight line equation. You can see this equation, y equal to ax plus c, where a becomes the slope of the line and b is the y-intercept, which is indicated here. So any scatter of a point, if I try to fit it in a straight line, then it will definitely give me a straight line equation which will represent the nature and scatter of such points. So this concept we are using for establishing a relationship, and on this concept only we will develop our regression model. So in this particular video today we are developing a simple linear regression model which is called as SLR model. So our SLR model will be in the form of y equal to ax plus b, because we will try to fit it in a straight line fit. Now let us come to the example. See, if we take a case of performance of swimmer, what are the parameters? As we already discussed, we have selected the measure of betterness as swim lap time. So you can see in the picture, this is a swimming pool. So lap time will be a swimmer will start from here, go there and return to the start point. Whatever the time in seconds or minute the swimmer will consume, it will be termed as swim lap time. And definitely, as we are talking about a performance of swimmer, so we are targeting to minimize this lap time. But what are the factors which will affect this lap time? So as we already discussed, age, weight, sex of the swimmer, all these factors will impact the lap time. So I can say definitely logically about weight, that if the person is heavy, he will feel more difficulty in the swimming. Obviously some part of practice and treatment will be there, but I am talking about a logical relationship, that if the weight of the swimmer is more, he will feel more struggle in the swimming, due to which his or her lap time will be more as compared to the swimmer who is slim or less in weight. So this is our general understanding. So let us do the factor analysis. What are the factors which will affect the performance of swimmer? So here you can see the entire categorization. On the left side, you can take speed of a swimmer, which is a function of time only, but we have selected as lap time. So if it is a lap time, we will minimize it. If it is a speed of swimmer, we will maximize it. In today's case, we are selecting lap time. So our target is to minimize the lap time. Now, what are the factors which will affect this lap time? So factors related to swimmer are, as we already discussed, age of the swimmer, sex of the swimmer, weight of the swimmer, and height of the swimmer. There may be more factors, but we are just discussing the conceptual aspects. Then there will be some factors related to system also. So what is the length of swimming pool or swimming lap? What is the temperature of water? What is the ambient temperature outside? And what is the terrain? So terrain is one of the factor which will not play a role when it is a swimming pool, but when we talk about swimming in a natural terrain like river, then many more factors will be added like upstream, downstream, what is the speed of stream of the river and everything. But as of now, if it is a swimming pool, then it is a still water and there is nothing like terrain. So swimming pool is well dimensioned and equipped with standard terrain. So what is the terminology? One terminology we already discussed. Measure of betterness is affected by factors. So there are some other names also which we will discuss. So on the left side, these are the alias names for measure of betterness and these are the alias names for factors. So one relationship is also called as effect affected by the causes, then response affected by the variables, and dependent variable affected by independent variable. So this is the terminology which is parallelly used for measure of betterness and factors. So let us proceed. The data which is collected for swimmers. So you can see here are 6 columns. So we have collected data like swim lap time. Obviously we have taken a sample of 10 swimmers. So we have collected the data for 10 swimmers. So their swim lap time, their age, height in centimeter, weight in kg, then water temperature in degree Celsius and ambient temperature. So we already know our dependent variable or we can say a measure of betterness is swim lap time, which is affected by the other 5 factors. So as I already said, this lecture is about simple linear regression. So if I want to measure the relationship of swim lap time with any other factor, I can select only one factor at a time. So in simple linear regression, only one factor is allowed at a time. So we can take any one factor. So we are selecting measure of betterness as swim lap time and we will denote it by y. So dependent variable is always y. Keep this in mind. X is always independent variable and y is always dependent variable. So X we are selecting the first column that is age of the swimmer. Now here we are interested in knowing the relationship of swim lap time and age of the swimmer. So how we decided that y is swim lap time? Because we cannot say that the age of the swimmer will depend on the swim lap time. But we can say that the swim lap time will depend on the age of the swimmer. So our y is swimming time or we can say swim lap time and x is the age of swimmer. So in the next slide we have steps to develop the SLR model. The steps are very simple if you understand it sequentially. So let us concentrate on the step. First step is to decide the dependent factor y and independent factor x. As this is the SLR model, there will be only one x and one y. So we have already decided what you know that y is my swim lap time and x is my age of swimmer. So I have already decided x and y. Then second step is to calculate mean of x and y. So here it is called as x bar and y bar. Then the third step is, the underlined green part is very important. Third step is we will calculate sum of product of x deviation and y deviation. Now what is this deviation? How much the value of x is deviating from its own mean. So you can see x minus x bar is x deviation and y minus y bar is y deviation. So we are taking sum of product of. I will explain it later in a table. Then fourth step is sum of square of x deviation. So it is summation x minus x bar square. Then fifth step is calculate slope A as the ratio of step 3 and 4. So we already have step 3 equation and step 4 equation. So we will take a simple ratio and we will get a slope small a. Then sixth step is calculate intercept B from this equation. So y bar is equal to ax bar plus b. It is a straight line equation. So we will put a value of x bar, y bar and a in this equation and you will get the value of b. Now you have value of a and b. So we will draft our SLR equation in the form of y equal to ax plus b. So these are the 7 extremely simple steps by which you can develop SLR model. So this is the data for SLR. We have selected one X, that is age of the swimmer, and Y as swim lap time. So see, whatever the things we are needing as per the 7 steps. So we are needing X deviation, Y deviation, product of X deviation, Y deviation, and square of X deviation. So we are making 4 extra columns, which is the requirement for making the SLR model as per these steps. So we will do the calculations. So y bar is calculated as sum of all readings upon number of readings. So you can see here sum of all reading is 269.8 and there are 10 readings, so mean becomes 269.8 divided by 10, 26.98. So this is a y bar. Similarly, for the age, the sum of all the readings is 252 and readings are 10, so mean becomes 25.2. This is x bar. So this is y bar and this is x bar. Now in this column we will put the value of x minus x bar. So first value will be 22 minus 25.2. Accordingly this column will be prepared. Then y minus y bar will be 25.3 minus 26.98. Likewise this column will be filled. Then multiplication of this and this column will be this column and square of this column will be this column. Now see, this column is prepared. So we have calculated all the values and filled all the values in this table. Okay, now as per the steps, step number 1 was select y and x, so we selected it. Step number 2 was calculate y bar and x bar, so we have calculated it. Third was sum of product of. See, this is product of x deviation and y deviation. So this product, we are taking a direct sum of this. So that sum is coming 42.14, step number 3. And step number 4 is sum of square of x deviation. So this is the column called as square of x deviation. And the sum of square of x deviation is 185.6. So here in the steps, this is mean of x, y, then this is sum of product of x deviation, y deviation 42.14, then sum of square of x deviation, it is 185.6, then slope is the ratio of step 3 and 4, so 42.14 divided by 185.6, it comes 0.227. Then intercept B will be calculated by this equation. So putting y bar, a and x bar in the equation, we get b, which comes out to be 21.259. Now we have the values of a and b. So SLR equation will be in the form of y equal to ax plus b. So we have to write it like this: y equal to ax plus b. The value of a is 0.227 and value of b is 21.259. Now what will be our SLR equation or SLR model, we can say? The swim lap time will be predicted by the equation 0.227 into age of the swimmer plus 21.259. So this equation is called SLR equation or SLR model, and this model can predict the value of swim lap time based on any value of x, that is age of swimmer. So now once this model is prepared, you just put the age of the swimmer and you can predict that what will be the lap time of that swimmer depending on his or her age. So this can facilitate decision making. So that's all for today's lecture on SLR. I hope you find it effective. Any questions after watching the entire video, you can put in the comment box. Thank you.